The next item on the agenda is an information item to provide us with a technical briefing on management systems in the nuclear industry as outlined in CMD 16M22. I'll let CNSC staff get set. And I understand Mr. Lamar, you'll make the presentation. Over to you.
Good afternoon, Mr. President, members of the Commission. For the record, my name is Greg Lamar. I'm the Director General of the Directorate of Safety Management. It's my pleasure and the pleasure of DSM staff here today to be in front of you to take this opportunity to brief on the topic of management systems in the nuclear industry. On my left are Monsieur Pierre Lahaye, who's the Director of the Management Systems Division within DSM, and Mr. Gabriel Giobi, who's a Management Systems Specialist within the Management Systems Division. They'll be presenting today's material, and I will turn the floor now to Monsieur Lahaye.
Thank you, Mr. Lamar. Pierre Lahaye for the record. The CNSC has continued to evolve its understanding and expectations related to licensees' management systems since its introduction into the regulatory framework in 2009. The objectives of this presentation are primarily to provide fundamental information on the subject of management systems and relate this to the current approach the CNSC has in place for the regulation of licensees' management systems. All of this, as you will see, is of high relevance to safety in the nuclear industry. Mr. Giobi and I will be presenting information on the topics listed in this outline. Mr. Giobi will begin with some introductory information on management systems as a whole that will help explain how we got to where we are today and further explain how the nuclear industry has adopted management system practices to ensure safety. Much as this has been informed by the International Atomic Energy Agency guidance and reflected in the Canadian Standards Association Safety Standard for Nuclear Facilities, CSA, and 28612. I will then relate to what the CNSC does to regulate licensees' management systems, compare what we do with other nuclear regulators, and talk about our approach to oversight. We will conclude with a quick view of what is anticipated in the near future in the area of management system development, as well as some key messages from this briefing. I will now hand over to Mr. Giobi, who will proceed with the presentation.
Thank you, Mr. Lahaye. Good afternoon, Mr. President and members of the Commission. My name is Gabriel Giobi, and as Mr. Lamar stated, I'm a Management Systems Specialist in the Directorate of Safety Management. There are many definitions of management systems in standards literature. For example, the ones developed by the standards organizations identified here. The wording in the second bullet captures the essence of these various definitions as it speaks to all tasks required to achieve objectives. The word task includes any activity, as simple as making a decision, to the complexity of a large program. Management systems and standards are modeled on the Plan, Do, Check, Act approach, originally developed for quality and commonly referred to as the Deming Wheel. This approach has been a key driver in the evolution of management systems from quality control to integrated management systems. Since early history, quality control has been associated with verifying that an item has met a specification. This was the primary means of meeting requirements. In time, this was seen as risky and wasteful. With that in mind, the concept of quality assurance became widely practiced as a means of ensuring processes delivered expected results consistently. This was accomplished by incorporating practices that enabled better management and control of processes. These practices were further evolved into the broader quality management approach, often associated with total quality management, where quality assurance principles were applied more broadly and at higher levels in the organization. Today, we're at the phase where a single management system can be implemented that incorporates quality control, quality assurance, and quality management principles to achieve all of the organization's objectives. An integrated management system is a means by which an organization, through the systems approach, implements practices that are applied across an organization to achieve all of its objectives and meet requirements. The blue Venn diagram at the center of the slide serves to illustrate how the principles of quality control, quality assurance, and quality management have served as the building blocks of an integrated management system. This evolution has seen the accountability of management systems shift in practice from the quality organization to top management. It is important to note that in keeping with this evolution, the IAEA and CSA standards on quality assurance for safety-related systems and activities have evolved to management system standards that integrates all requirements while maintaining safety as the paramount consideration. In order to better understand how the principles of quality control and quality assurance are included in management systems, as shown in this hypothetical model, it is useful to consider them in practical terms as captured by management processes. Quality control is the primary means of verifying that an item or a process output meets a specification by direct comparison to that specification. On its own, quality control provides little, if any, focus on safety and does not have much impact on safety performance. When the practice of verification during or at the end of a process is included with key quality management processes which are common to quality assurance standards, better management and control of processes is assured. These quality assurance processes are the embodiment of the Plan, Do, Check, Act approach that provides assurance of consistent results in meeting requirements. When applied to safety-related items and activities, as they are in the nuclear industry, these processes have a greater influence on safety. An integrated or single management system builds on the principles and processes of quality control and quality assurance by applying them to all activities while upholding the principle that safety is the paramount consideration in all decisions and actions. In an integrated or single management system, there is also a broadening in the application of quality management processes such as nonconformance and corrective actions to an overall process on problem identification and resolution. Equally as important is the addition of self-assessments and the use of experience, which are beneficial to ensuring continuous improvement. These additional practices and the incorporation of the key principle of safety enable an increased focus on safety with an expected increase in safety performance. A well-designed and effectively implemented management system provides many benefits to an organization, as outlined here. Additionally, a management system also provides order and structure to ensure that the management system can provide the right information at the right time in order for the right decision to be made. From a regulatory perspective, it is very important that an organization ensure consistency in achieving objectives and in meeting requirements, that the organization demonstrate compliance to the regulator and identify all risks and implement mitigation measures. A management system is typically modeled on a standard, which identifies various requirements. This model contains generic elements that are common and core to many standards. The generic elements listed here are in line with Plan, Do, Check, Act, as discussed earlier. This model can be found, for example, in management system standards for quality, environment, occupational health and safety, and numerous others. By implementing management processes aligned with these core elements, a single or integrated management system may be developed. So what is meant by the term integrated management system? An integrated management system is comprised of all the generic management processes and practices, as well as the specific processes and practices to meet requirements of one or more management system standards. The term integrated management system is used to denote a management system that integrates the sector-specific requirements into a single management system. This illustration is an example of an organization that needs and wants to meet the requirements for quality, environment, occupational health and safety, and security. An organization can choose to manage these activities separately, as shown by the middle grouping, or an organization can choose to consolidate the generic requirements into a single set of management processes which are applied to all the specific processes aimed at achieving the various requirements, as shown by the larger circle on the right. One very important benefit in consolidating or integrating the management system is having the management ability to assess and improve on all objectives in an integrated manner. This allows for better comprehension of how decisions made for one set of requirements could impact others. This is the approach the IAEA has adopted as a means of enhancing safety. The IAEA document titled Fundamental Safety Principles is a central set of expectations within the IAEA's framework of safety requirements and safety guides. Principle 3 of this fundamentals document highlights the expectations of a management system in that leaders are engaged, the management system is effective, it integrates all aspects of management for safety, promotes a safety culture, provides for assessments of performance, and the use of lessons learned from experience. These management system expectations were further explained in the Safety Requirements Document, GSR 3. The IAEA published the safety standard GSR 3, titled The Management System for Facilities and Activities, in 2006. Since its publication, it has been adopted by numerous member states as a management system model. GSR 3 requires that an organization integrate the requirements for safety, health, environment, security, quality, and economics into a management system. This is to ensure that safety is properly considered in all activities by giving it paramount consideration. As an aside, we should mention that the IAEA also expects member state regulators to adopt GSR 3 as the guidance for their own management system. It is worth noting that the CNSC's management system is aligned with GSR 3 and was evaluated as meeting all the requirements by the IRRS mission in 2011. The CNSC understood and accepted the benefits of this approach for the regulation of licensees' management systems and adopted it in 2009 when the safety and control area of management systems was introduced into the regulatory framework. This was an evolution from the previous requirement for quality assurance. There was a similar realization within the Canadian nuclear industry that this approach should be reflected in the Canadian Management System Standard, CSA N286. The CSA N286-12 standard, titled Management System Requirements for Nuclear Facilities, was published in June of 2012 and has been adopted by the CNSC as the standard of reference for all Class 1 and uranium mines and mills licensees. This latest version of N286, prepared and accepted by a cross-section of the Canadian nuclear industry, is the first to have its scope expanded beyond nuclear power plants. It is aligned with the principles of the IAEA Guidance and represents industry's best practice. The N286 standard integrates requirements from other management system standards for quality, health and safety, environment, economics, and security. This was accomplished by considering a number of management system standards, including GSR 3. As a result, a key principle of the standard is to ensure that safety is a fundamental consideration in all activities. As with its predecessors, this standard applies to the life cycle of a nuclear facility, from conception through to decommissioning. A commentary document to the CSA N286-12 standard was also published to provide background information helpful for the implementation of a management system in line with the intent of the standard. We mentioned earlier that the structure of management system standard can provide a sound model for an organization's management system. This is equally true for N286. As shown by the triangle on the left side, the CSA N286-12 standard consists of a set of 12 principles supported by 12 generic requirements and a set of specific life cycle requirements classified by facility type. The structure of the N286-12 standard is simple, yet provides for a comprehensive application of management system principles in all activities. These principles are incorporated into the generic management process requirements and are considered when these are put into effect. Both the principles and the supporting generic elements apply to the lifecycle specific requirements. This structure aligns well with what is considered a typical or ideal management system, as depicted by the triangle on the right. This relationship of the upper tier policies to the second tier management processes are incorporated into procedures and work instructions. This relationship aligns well with the structure of the N286-12 standard. An example of how this works would be in the supply chain. Organizations normally have a quality policy as the top tier document that applies to all procured items and services. The procurement process, which lines up with the second tier of the triangle on the right side, will emphasize the importance of ensuring quality through key activities such as supplier qualification, ongoing supplier survey activities, receiving and incoming inspections, and storage. The bottom tier procedure of the triangle will include procedures for incoming inspections, which will include work instructions on how to identify non-conforming as well as suspect items, and how to follow up to determine if there is counterfeiting or fraud involved. Understanding the structure and the intent of the CSA N286 standard is useful when considering how the CNSC regulates and sets expectations for licensees' management systems. And now, Mr. LaHaye will continue with this briefing.
Now we turn your attention to how the CNSC regulates licensee management systems. This slide illustrates an example of the CNSC regulatory framework for nuclear power plants as it applies to management systems. The Class 1 regulations state that an application for a license must contain a description of the proposed quality assurance program for the activity to be licensed. In 2009, the license condition associated with the Class 1 regulation for a QA program was updated to a license condition for the implementation and maintenance of a management system. We should note here that, in keeping with this change, the regulations for Class 1 and uranium mines and mills are in the process of being updated to express a requirement for a management system. The license condition handbook referenced in the license contains further expectations on the scope of the licensee's management system, as well as the standard to be used. Under the Safety Control Area of Management Systems, a license condition handbook for a nuclear power plant, the example here being the latest for Darlington Nuclear, details the CNSC expectations for the performance objective, management system requirements, and associated compliance verification criteria. The performance objective is for an effective management system that integrates provisions to enable the achievement of safety objectives, ongoing performance monitoring, and maintaining a safety culture. The management system requirements preamble includes a commitment and adherence to management system principles and the establishment of processes to achieve the desired results. It also states that the CSA N286 standard contains the requirements for a management system throughout the life cycle of a nuclear power plant that extends to all safety and control areas. For the compliance verification criteria, it states that the management system shall comply with the requirements set out in CSA N286 management system requirements for nuclear facilities. Excuse me. So how does the CNSC's approach to regulation of management system compare internationally with other nuclear regulators? A recent benchmarking exercise provided us the comparison presented here. For the USA and other IAEA member states having a similar regulatory model for management systems, such as Korea and Japan, the requirement is for a prescriptive quality assurance program for safety-related items and activities. There isn't a stated requirement for a management system applying to all licensed activities. The US NRC endorses the American Society of Mechanical Engineers Quality Standard, NQA1, as a model for meeting their regulatory requirement. It should be noted that the US NRC has a regulatory guide entitled Quality Assurance Program Requirements for Operation. In it, they state that this guide incorporates administrative and quality assurance controls for the operational phase, which is consistent with the basic safety principles provided in the IAEA safety standard GSR-3. Regulators in Europe, such as in the UK, France, and Finland, require the implementation of a management system, often citing GSR-3 as a standard that should be taken into account. The requirement is for licensees to have a management system that gives due priority to safety. Each has their own way of specifying this. For example, the Office for Nuclear Regulation, ONR, in the UK, state that the licensee shall, within its management system, make adequate quality management arrangements in respect of all matters affecting safety, and that these arrangements be based on current national or international quality management system standards. They then cite GSR-3 as relevant good practice, and other standards such as ISO 9001 may be used provided they demonstrate how it is applied to all matters that may affect safety. In Canada, as we have seen, the CNSC requires Class 1 and UMM licensees to have and maintain a management system as a license condition, supported by a requirement to adopt CSAN 286, which is an industry consensus standard which applies to all license activities. In our view, this places the CNSC as a leader in the regulation of management systems and management system expectations. One way of visualizing the CNSC expectations for licensee management systems is to view the management system as the umbrella which governs all license activities. The management system standard is often referred to as an umbrella standard. Licensees are expected to implement and control activities aimed at fulfilling the requirements of various standards and reg docs in accordance with their management system. The licensee's management system extends to all safety and control areas across all lifecycle activities, which include design, procurement, construction, commissioning, operation, and decommissioning. The diagram in the bottom right is a simple illustration depicting the management system processes, which extends to all safety control areas and associated specific areas. The CSA N286 standard, which has been adopted by nuclear power plant licensees as well as other Class 1, UMM, and waste licensees, represents the industry current best practice for management systems. It includes a set of principles fundamental to management processes and features important to ensuring overall safety. The CNSC's expectations for licensees is that they adhere to the principles listed here as the basis of their management system and the corresponding management processes. The first two principles are aimed at ensuring that safety is properly considered in all decisions and actions, and that licensees are expected to design, plan, and control their activities to meet all requirements. As captured in the next three principles, this includes ensuring the organization is aligned and able to establish, communicate, and achieve the objectives and priorities it sets for itself. The rest of the principles are meant to ensure that processes are established for managing activities consistently, for verifying that the desired objectives and requirements are met, and for self-correcting to address deficiencies and to improve. These principles are captured in the current version of the Management System Standard and are further expanded in a corresponding set of generic requirements. A management system implemented in accordance with these principles and requirements has features to assure good safety performance. The current best practice for management systems in the nuclear industry is to have features conducive to the management of activities for good safety performance in meeting objectives. As we mentioned earlier, in order to achieve this, it is necessary to ensure safety is of paramount consideration in all activities. It is a responsibility at the highest level of management to ensure this is well communicated and supported by the organization in order to better understand and promote a safety culture. Organizations should develop a single management system that integrates all management system requirements, as this contributes to optimal performance by emphasizing that all activities and decisions can have an impact on safety. The management system must apply to all life cycle activities, whether they are conducted by the organization or for the organization by a contracted external party. With a graded approach, management system requirements may be implemented to the extent commensurate with the complexity and safety significance of the activity. The management processes in place for assessing and reviewing performance are instrumental in understanding the thoroughness of the management system in promoting and supporting human performance. The relationship of the management system to safety culture and human performance is key in delivering good safety performance. The management system sets expectations for and supports human performance and safety culture by providing the mechanisms by which an organization can plan, do, assess, and correct its activities to meet requirements and improve on performance. In this way, the management system is the vehicle by which safety is managed, performance is optimized, and safety culture is further enhanced. CNSC staff verify licensees' performance and compliance with requirements through a number of compliance activities. Desktop reviews of licensees' management system and process documentation is conducted periodically to ensure the requirements are addressed and that changes to these do not negatively impact safety. Compliance inspections on key management processes and lifecycle activities provide the assurance that these activities are conducted in line with requirements. In many cases, inspections conducted on specific licensee processes capture information regarding generic management processes such as organization, information management, which is primarily document and records control, resources, as demonstrated through training, change management, and problem identification and resolution. The reports produced are reviewed to capture the common management process information for trending. Similarly, all event reports from nuclear power plant licensees are reviewed for a similar purpose, trending of management system elements that may be deficient. Ultimately, CNSC staff make good use of compliance information as a source of feedback on the performance of the management system, which is a good leading indicator to potential performance issues. So, what's next for management systems in the ongoing evolution at the CNSC? CNSC staff contribute on an ongoing basis to the evolution of the CSA N286 standard. The CNSC is embarking upon the process of writing a reg doc on management systems to reaffirm and clarify expectations for licensees. As mentioned earlier, the Class 1 and uranium mines and mills regulations are being amended to reflect a requirement for a management system for the licensed activity. CNSC staff have contributed actively to the development of the IAEA standard for management systems. GSR Part 2, entitled Leadership and Management for Safety, was recently approved by the IAEA Board of Governors and is expected to be published in the next year. As the title suggests, there is an increased focus on the role of leadership for safety. The ISO 9001:2015 standard published recently also has incorporated requirements for the leaders of the organization. CNSC staff stay current with management system best practices with particular attention to developments that can further enhance safety. There are a number of key messages in this presentation, and we have chosen to highlight a few here as a conclusion. We want to emphasize in particular that safety is a paramount consideration in all decisions and actions. The management system has safety as a fundamental deliverable. Management system requirements apply to the life cycle activities as well as to all safety and control areas. The evolution of standards from quality control to integrated management systems was driven by the expectation that it would result in improved performance and safety. There is a direct relationship between an effective management system, excellence in human performance, and safety culture. The CNSC oversight of licensees' management systems is comprehensive and integrated and provides information indicative of potential performance issues. And as a concluding key message, the CNSC is leading in its approach to regulation of licensees' management systems through its adoption of industry best practice. Thank you. CNSC staff are now available for questions.
Thank you.